In this lesson we'll learn about pressure in liquids. Something to think about. Cruise ships are often made from iron and steel. Some of the biggest cruise ships are longer than 3 football pitches and weigh the same as 68,000 elephants. So why do you think they float when a small lump of steel will sink? Okay, well, I'm going to demonstrate now some floating and sinking of objects, and hopefully when we get back to this we can discuss why a cruise ship being so large can float when in fact if we had a piece of iron that would sink. Here I have a bowl of water and here is some plasticine, 2 balls of plasticine, roughly the same amount. The ball of plasticine has now sunk in the water, so placing the ball of plasticine in the water, it sinks. Now the same amount of mass I can then spread out, okay, form a flat disc and then raise the sides up, so I form a kind of boat shape. What I'm doing is I'm increasing the volume of the shape overall, and for roughly the same mass this now occupies a much larger volume. And now let's see what happens when I place it in the water. Okay, this time it floats. In that last demonstration I took a ball of plasticine, placed it in water and it sank to the bottom. Now if I took the same amount of plasticine and then I flattened it out and I formed a boat shape, so it was a much larger volume for the same amount of mass, that shape floated. So in terms of the original something to think about, a ship will float, quite happily float, because you're taking the amount of steel or iron that would initially sink if it was as one block, and you're creating a much larger volume. Okay, so the size of that ship is a very big volume for the amount of mass originally. So we'll come across this idea further on when we do some other demonstrations to do with liquid pressure, but for now we've come across this idea that something can have an amount of mass, but actually if you change the size of it, the shape of it, the volume of it, then what you're actually doing is you're changing its density. So the rest of the lesson then, the outcomes will be: describe how liquid pressure changes with depth, and explain why some things float and some things sink. Mass versus weight. So I've just discussed something to do with a boat not sinking, and I mentioned the words mass, I've mentioned the words weight. So what are these things? Okay, so this asks what weighs more, a kilogram of feathers or a kilogram of iron? Okay, so you can think about that, and I'm going to show you a video and then we'll get back to this question. Here I've got some scales and I'm going to measure an amount of Rice Krispies, and that amount is going to be 100 grams. So there's not really a need to be so precise, but I'll get it to pretty much as close to 100 grams as I can. And what I want you to look at is just how much volume 100 grams of Rice Krispies occupies. Okay, so there's quite a lot of Rice Krispies there, 100 grams of Rice Krispies. There we go, so that's the volume of Rice Krispies for having 100 grams of it. So we've got a mass of 100 grams and there's the volume. So now I'm going to put the pan down and I'm going to measure out 100 grams, but this time of water. Okay, and one thing to notice, the amount of mass is going up quite rapidly and there's not as much water. Okay, so remember the Rice Krispies, the volume of Rice Krispies 100 grams took up. Well, for water there is a lot less volume for the same amount of mass. Okay, and so there's this idea of how dense an object is how much mass you can squish into a certain size volume, and the water is much smaller in volume, so more dense. So I tried to show you if I got some scales that will tell me the mass of an object, and I put some Rice Krispies on the scales until I had 100 grams of Rice Krispies, and then I put in 100 grams of water afterwards. And so this idea of mass, if I were to say what weighs more, a kilogram of feathers or a kilogram of iron, then we need to really understand what we mean by weight. Okay, and weight is linked to mass. Okay, mass is measured in grams or kilograms. Weight is actually a force measured in newtons, and that's the amount of pull the Earth will pull down an amount of mass. Okay, and on Earth it's 10 newtons for every kilogram of mass. So asking if what weighs more, a kilogram of feathers or a kilogram of iron, well, they're both the same mass. There are a kilogram of feathers and a kilogram of iron. And on Earth, a kilogram has a weight of 10 newtons for every kilogram. So the feathers would have a weight of 10 newtons and the iron would have a weight of 10 newtons. They're the same. Likewise with the Rice Krispies, I had 100 grams and the water that I poured in the scales was also 100 grams. So in terms of which one weighed more, well, they weigh the same. However, what was different was the actual volume of the Rice Krispies in comparison to the volume of the water. Now clearly a larger volume, so the Rice Krispies occupied a much larger volume for the same amount of mass. And another physical quantity that's we need to discuss here is density. So the Rice Krispies are not that dense. Okay, for the 100 grams of mass, all that stuff occupied such a large volume, it wasn't very dense in comparison to the water, which for the same amount of mass, so all those particles were crammed together and compacted into a much smaller volume. So the water was more dense. Okay, and likewise with the feathers and the iron in this example, even though you could weigh out a kilogram of the feathers and a kilogram of the iron, the feathers are not that dense in comparison to the iron. Okay, so a kilogram of feathers would occupy quite a large volume, whereas a kilogram of iron wouldn't occupy that much of a volume because it's very dense. Now, the PowerPoint presentation discusses watching a demonstration about floating and sinking and looking at water pressure, and then when you were to watch these demonstrations, you would think about making a prediction if something would float or sink. I'm going to do something slightly different. I'm going to show a range of demonstrations to do with water pressure and also a bit of floating and sinking, and then we can get back to this and we can discuss what we've seen. This demonstration is simply showing that as the depth of water increases, pressure increases. Here we have two different liquids. The red liquid is actually water just with some food dye in, and then the yellow liquid is oil. If I remove some of the red liquid and I place it into the yellow liquid, what we'll find is the red liquid sinks down. Okay, so the red liquid is denser than the yellow liquid, so water is denser than oil, and the oil layer floats on top of the water. Okay, so just demonstrating here that if I put any water in the oil layer, it'll just sink down. Now what I'm going to do is the opposite of that. I'm going to take some of the oil layer and I'm going to put oil droplets in the water layer, which is difficult to see because it's red, but hopefully you can just make out that the oil is then rising up. Okay, so it's floating to the top of the water layer. So that's demonstrating that there are different densities of fluids. Some will sink if they're more dense, and the less dense ones will float. The ice here, it's floating on the water, but it's sinking in the oil. Okay, so it's not, it's dense enough that it sinks in the oil layer, but it's less dense than the water, so it floats on the water layer. In this demonstration, I'm going to take an orange and I'm going to place it in the water, and the orange floats. Okay, so that's the first part of this demonstration. what I'm going to do now is I'm going to remove the orange, and I'm going to take the peel off the orange. So I'm going to peel the skin off the orange. Okay, and so if we think about what I'm doing here, I'm actually removing mass. Okay, so we're taking away some stuff, and so it has less mass, and subsequently it would weigh less. So the orange floated before with the skin on. Now I'm removing mass, so it should weigh less. So do we think it's going to float, or do we think it's going to sink? Okay, I'll say that again. We're removing mass, it weighs less, it floated before. Does it float still, or does it sink? This time it sinks. Having seen the demonstrations, let's discuss these questions. How does water pressure change with depth, and why do you think this is? Well, to explain this, think back to the demonstration with the milk carton. There were 3 holes. There was a hole at the bottom, hole midway up, and then a hole right at the top of the milk carton. And the water was pushed out at different amounts depending upon how much water was above the hole. So at the bottom, there's a lot of water above, a lot of weight of water pushing down. So the bottom hole was at high pressure, and so the spout of water came out very far. The hole further up has less water above it than the bottom hole, so it's a reduced pressure in comparison to the bottom hole, so the water spout didn't come out as much. And then finally, if you go higher up, the top hole, there's hardly any water above that hole, so there's hardly any push from the water above, so that was the least amount of pressure, and so the least amount of force that water was pushed out with, so the spout didn't push out as much. And so what that demonstrates is liquid pressure, or in this case the water pressure, actually increases with depth. And the reason being is the deeper down you go, the more water is above you, so the more weight of water pushing down on you. Did you see a pattern between objects that floated and objects that sank? Well, I didn't demonstrate a range of objects, and we didn't look to see which one's going to float, which one's going to sink, but I did show a number of demonstrations that did look at things that sank or things that floated. One of them being the water with food dye in, the red food colouring. That sat at the bottom, and then I put oil, which is less dense than water, and it floated above the water because it's less dense. I also tried to demonstrate what would happen if you tried to put the water in the oil, and beads of water in the oil actually sank down to the water level, the red water level. If I took some oil and put it into the water at the bottom, that oil would float up and join the oil layer. Okay, so if something's going to float or something's going to sink, well, it totally depends on the density of that fluid. I finally put some ice cubes in, and what happened there was when they dropped in, they kind of dropped to the bottom at first because of the force at which I dropped them, and then all of a sudden they rose up to the top of the water layer, but didn't float on the oil. Okay, so what that's suggesting is ice is actually less dense than liquid water, but more dense than the oil. Another demonstration to do with floating and sinking, I took an orange, and when I put the orange in the water, it floated. However, interestingly enough, when I removed the peel, so I was actually taking mass away from the object, so it would weigh less. You would think, well, if it's floating before, surely it's going to float when it's got less weight pulling it down. But actually, what we're also doing is we're reducing the volume as well. Okay, and so what's happened overall is we've changed the density of the orange. Okay, so it went from being a certain density with its skin on, and then when we removed that peel, it suddenly changed its density, and it actually became more dense, and it sank. Okay, so it became more dense than the water. But at first you would think removing the peel, surely removing mass, so it's less weight, it's actually going to still float. But what we also did was we reduced the volume, and that volume actually had probably air pockets within it, and it was almost like a life jacket around the orange, keeping it afloat. Okay, so we've seen a number of demonstrations, and hopefully the questions that we've just looked at, you would be okay with answering those questions. This final demonstration is to make a Cartesian diver. You'll need a straw. So I've cut a piece of straw. If you bend the straw like that, you then need to take a paper clip. You attach the paper clip to the straw, so just put it through the tube part of the straw, and then you end up with something that looks like this. And then what you'll have to do is add another paper clip, because you need this to have a little bit more weight. Now, depending on your straw, if you've used a larger straw, you might need a few paper clips. And then you're going to place your diver in a bottle of water, and you're going to put the lid on the water. Now, if you squeeze the bottle, what happens is the diver sinks. And then if you let go of the bottle, the diver floats. To explain what's happening, we need to have this idea of why something might sink or float, and also the fact that gases can be compressed, whereas liquids cannot be compressed, they're incompressible. And so the reason why things float or sink is to do with the forces involved. So if something has a weight to it, and the weight is greater than the force that can keep it up, and this force is called upthrust, then it will sink. So once this diver is too heavy, it will sink. And this is the reason why it can change its weight. In the tube, you can see there is air. Air can be compressed. So when you squeeze the bottle, increase the pressure inside the bottle, water is pushed up into the tube, making the diver heavier. And so the upthrust force now isn't great enough to hold the diver up, and the diver sinks. To summarise what we've discussed and seen today, let's just look at this, the key points. So this lesson I have learned liquid pressure is the pressure produced by the collisions of liquid particles. Liquids are incompressible. Liquid pressure increases with depth, and an object floats when the number of water molecules hitting the bottom of the object is greater than the air molecules hitting the top.